thought I'll start with that way, and I'll share with you some of the success stories also. And in case you find any issues in between, if the slide is not moving, kindly let me know, because I'll not be able to find it out from my end. So kindly cooperate in that. So let's begin. We all know that per capita energy consumption of a country is a measure of country's prosperity. And we in India have a very low per capita energy consumption as compared to other developed countries of the world. Also, the available conventional resources of energy are scarce, and this calls for proper utilization of the resources and energy. Here, energy management and energy audit are greatly required. So, if you talk of the world energy scenario, the total consumption of the marketed energy is expected to expand by 54% from 404 quadrillion million BTU. It is British thermal units in 2001 to 623 quadrillion British thermal units in 2025. And of course, we have been listening that oil and gas reserves are limited for us. Then comes the story of United Nations, wherein they have formulated 17 strategic goals, and out of those strategic goals, some of them relate to energy. For example, if you look at them from another angle, we have got the 5 Ps, wherein they are people centric. They want to end poverty and hunger from all forms and ensure dignity and equality. Prosperity is to ensure prosperous and fulfilling lives in harmony with the nature. Peace, foster peaceful, just and inclusive society. Partnerships, implement the agenda through the solid global partnerships, and planet is to protect our planet. So these are the sustainable development goals, 17 of them, which United Nations has formulated. We are more concerned on goal number 7, which is to ensure access to affordable, reliable, sustainable, and modern energy for all. That includes our villages, which, as it is, were not in there in the earlier programs. Now, in goal 9, build resilient infrastructure, promote sustainable industrialization, and foster innovation. That is also related to the energy part, because a resilient infrastructure and sustainable industrialization will not be possible until and unless we use the available resources of energy, or we develop these renewable sources of energy for our use. Goal 12 is to ensure sustainable consumption and production patterns, wherein you are supposed to be consuming responsibly and also producing responsibility. I might be producing a lot of energy from coal, but I'll not. That is not clean energy. That is causing a lot of problems of pollution and other related problems, right? All right. Then take in 13 goal number 13, which is take urgent action to combat climate change and its impacts. Now, why is the climate change happening? You've just recently seen a catastrophic result of the climate change in Turkey, and today morning, if you are just following the news, we also had an earthquake in Mizoram. It's a small intensity, 3.8 only right now. But these are all the result of a lot of issues which have come up because of the climate change. So let us talk about the Indian scenario. Absolute primary energy consumption of ours is only 1/29th of the world, 1/7th of USA, 1/1.6th of Japan, and but 1.1 times of Canada, and 1.3 times of France. This reflects the population density also. 59% of the primary energy source available right now is coal. And if you talk of energy usage in the country, this is just an example giving you how badly we need to go into this. We have been talking of million tons of oil equivalent, and each time when we compare or we want to have a base for the energy, it is basically the tons of oil equivalent, which is a unit of energy. It is the amount of energy released by burning 1 ton of crude oil. Approximately, it is around 42 gigajoules. So, to rationalize or to compare the various forms of energy and various units of energy, what is done is that they are all brought down to a same baseline using this MTOE, which is million tons of oil equivalent. So one barrel of oil equivalent contains approximately 0.146 tons of oil equivalent. There are approximately 6.841. This just to give you an idea about the energy part. And now what we are doing, our demand has been increasing day by day. You see, earlier hardly any house had television, and if you talk of villages, televisions were missing. Only one in the whole village. Once it came down, everybody used to watch, and now every house in the village also has a television, if not two, at least one. Then air conditioners have come up, then mobile phone charging is there, then induction heating is coming up, and so on and so forth. The demand has been increasing exponentially. So this is putting burden on our energy security, and it is having an adverse impact on the environment. So energy conservation and energy efficiency are an essential part of the national energy strategy. Okay, so before we talk of smart villages and we talk of the renewable energy options available, just a glimpse of some of the already implemented ones. Because I'm just putting them here, I could have put these slides in the end also, but I thought uh, it is better to exemplify rather than preach. So exemplifying the thing is there. Now, if we talk of this village, this is the Gosaba Island, which is situated in Sundarban regions of West Bengal, and is surrounded on all sides by tidal rivers connected by with Bay of Bengal, which brings water of high salinity, not suitable for irrigation. Now, what is required is you need to irrigate. So, what they have done, good quality groundwater is also not available. So, due to these difficulties, farmers were unable to grow the rabi crops. And what happened? These people then envisaged solar power drip irrigation, and with that, the area is now becoming a hub for producing the vegetables and crops. To increase the crop area, solar power drip irrigation technology was introduced, and it was under one of the projects of the government. Then there is another example of a smart village which runs on solar power. This is Chotke village, deep inside the Setkosia Tiger Reserve. Now, what happens in such areas is it is very difficult to lay the, if we talk of the transmission line, it's very difficult to lay the transmission line. It is very difficult for the people to go inside and put the transformers. And again, who is going to look after them inside those villages, in remote areas? So that is where the solar is coming into in a big way. This is in Odisha. 150 homes have access to electricity and have well-lit street lights. This is despite the village not being connected to the state or any national grid. Now, this is a microgrid basically. Chotke village is what experts at the International Corps Research Institute for Semi-Arid Tropics call a smart village, where off-grid power supply exists through the setup of solar plants by using hybrid renewable energy resources for generation. And this setup is automated. So this is basically another example. And let's talk of what is a smart village. We have all been you have all been doing talking of the smart villages for the last few days. The smart village has access to sustainable energy services, acts as a catalyst for development, enabling provision of good education, healthcare, access to clean water, sanitation, nutrition, growth of productive enterprises to boost incomes and enhance security, gender equality, and democratic engagement. So this is what is a smart village, right? Now, to talk of how do you get these facilities in the village? See, for getting this, you need energy. And how do you get the energy? Our villages have traditionally been um, agriculture, agri-based, and there's almost nil industry available. Sorry. Also, Um, some of the villages are located in remote areas. For example, if we talk of the hilly areas, or if we talk of the areas where tribals are living, they are cut off from the mainland. So the challenge here is that in today in the world, 1.3 billion people remain without access to electricity. In addition, 3 billion are still cooking on dangerous and inefficient stoves, which every now and then explode and cause loss of life, emit a lot of smoke and cause problems of breathing. Many of them live in remote rural village communities. Until such communities have access to modern energy services, little progress can be made to develop their economies and improve their lives. So, just again, some examples out here. Domestic electricity. This has been used in villages in Raigali Panchayat, which are electrified, and there are only a few households without electricity. Domestic lighting, televisions, few irrigation pump sets are the major loads in the village. Industrial and commercial consumption is negligible in the panchayat because it's a remote area, and the connected load profile and average monthly electricity consumption resemble a typical Indian village. Most of the houses in the village have connected load of 0.24 kilowatts, 20% in Raigali and Shivanali. They are two adjacent villages where the electric appliances include CFL and fluorescent lamps, televisions, general whatever is in the homes right now. There are a number of significant Bhagya Jyoti and Kutir Jyoti, which is BPL card holders, and in those areas, for BPL card holders, electricity is free. So it is challenge how to meet the expenses of delivering the electricity to them. The most of the this is also okay. Street lighting are provided with street lights, while other 14 villages have few street lights. Around by villages have few street lights. And then cooking and heating energy. Most of the households in the panchayat use LPG for cooking and biomass, which is fuel wood and agriculture residue. Now, using raw biomass and using a processed biomass makes a lot of difference. If I use wood directly, that is likely to cause more pollution than a processed biomass. We'll just talk of it later. For heating water, villagers use traditional cook stoves for which they collect fuel wood from nearby forests and use agricultural residue. Availability of biomass is declining due to less crop yield and declining trees in the forests, and some parts of the forests are inaccessible right now. So, technological intervention through alternate energy sources can indeed help villagers while saving the fuel wood and collection time. Interventions here include renewable energy options through solar rooftop, PV, and solar microgrid. Now, since the crop also is decreasing because the housing demand has increased, and since the housing demand has increased, people are into they want more houses. So the land is under the cultivation is shrinking, and because of that, you need now. How do you get the biomass? Biomass is only from the crop side. So then, since the crop area is decreasing, so biomass is also decreasing. The village receives abundant solar energy throughout the year, which ranges from 4.4 to 6.5 kilowatt hour per meter square per day. And this is a figure I have not purposely put this figure here because that would not be interesting to you. So, decentralized solar system basically what they are trying to do is they are trying to make a microgrid. I'll just let you know what is microgrid. I think you had a session on smart grid yesterday wherein you would have a flavor of the microgrid. Shayad, Mani Khanna ji would have discussed that also. So solar water heater is a viable option in the village since many households are dependent on traditional cook stove for water heating and fuel availability. Now here what they did was they set up a community water heating system. And in that, what they did, they found out what is the usage of hot water, or how much hot water is required by each household in the village. Combined that size, and then they designed a solar water heater system and put it in a central place on the panchayat land, and from there they supplied the hot water. So this is also a very viable option for these kind of projects. So, what are the drivers for alternate sources of energy? Why are we talking of renewable energy resources in the villages and that too in smart villages? The first driver came in oil crisis in 1970s. Then We have limited oil, natural resources. We have concern for energy security. We can't pay dollars for energy. And then there is an international management mandate for development of CDM technologies to reduce carbon, sulfur, greenhouse gas emissions, and phase out the fossil fuel generation and develop alternate sources. This is international mandate. IPCC 1998, then UNFCCC, Rio de Janeiro 92, Kyoto Protocol 97, and Copenhagen Summit 2009. These are the initiatives which actually have forced us to think of the alternate sources of energy, and keeping in view the international diktat and international mood, the government also initiated some plans for promoting alternate sources of energy that included the NAPCC, National Action Plan for Climate Change, and JNNSM, Jawaharlal Nehru National Solar Mission. Under this, a lot of work has been done. So we are one of the fastest developing countries in the world, and our population is only second in the world, first in terms of density, and we are soon to be first in the world also, as the projections are. Last 30 years have seen a boom in the power sector. Energy Act 2003. This is a game changer basically, wherein the electricity generation was de-licensed. You never, you don't have to take any permission. You can start generating on your rooftop, as people have started doing in here in the cities also. And sustainable energy is the need of the hour. All right. So, Government of India formulated a commission for additional sources of energy under Department of Science and Technology in 81 with an objective to formulate policies and research in the renewable energy. This is what the government has done. This was reformulated in 82 and as Commission for Non-Conventional Resources, upgraded in 92 through the ministry, which is now called as MNRE, and then this was further renamed as MNRE, New and Renewable Energy Resources. Non-conventional, actually, hydel is sometimes clubbed with non-conventional, so that is why they are not taking it here. The MNRE works in 5 major areas. What is the area? Let's first understand the crux or the top management or the top directions what people are going to give. So the first is the grid interactive renewable power. This is the mandate on which MNR is working, grid interactive renewable power. Now that includes wind, small, hydro, urban, industrial, waste to energy, solar power. Now what do you mean by grid interactive renewable power? Just to tell you that, it is basically you produce power at your own end and that can be supplied to the grid. If the power is not being generated at your end, you can take the power from the grid. If you are generating excess power, you are supplying power to the grid. So this is interaction between the grid and you. Then you have got distributed renewable power, for example, in biomass gasifiers, waste to energy, aerogenerators, and hybrid systems. Now, these are localized power generators. You have got, say, a biomass generator. It is installed in a village land and it is local to that village area, not connected to the grid. Then you have got rural and decentralized energy systems, wherein you have got family type biogas plants, solar street light lamps, home lighting systems. Herein, what they are doing is, under this MNRE schemes, they are setting up big biomass plants in the common village panchayat land and then supplying the energy and whatever is left, the manure from the plant itself, working as a sustainable mechanism in the villages. We just look at it a little later. Then remote village electrification is also there, and some other programs like Akshay Urja, Energy Park, and hybrid cars they are working on. MNR is working on it. Now let's come down to our electricity policy 2005, which states that there is an urgent need for promotion of non-conventional and renewable sources of energy. This is what is envisaged in the policy. Efforts needed to be made to reduce the capital cost of such projects. Adequate promotional measures would have to be taken for development of technologies and sustained growth of these sources. State Electricity Regulatory Commissions, SERCs, to provide suitable measures for connectivity with grid and fixed percentage of purchase from the renewable sources. Now, there is a mandate that you have to procure the energy from renewable energy. rather than from coal. Each state has been given a certain kind of a mandate. Punjab, it is approximately, I think now it is 10%, 10 to 12%. It is that way. So progressively, such share of electricity needs to be increased. That is the mandate. If you talk of renewable energy development in the country, this is a graph which shows how the timelines, how we have started. We started in 94, somewhere in 94, 95, 93, 94, when policy was announced. And then we have progressed from hydropower, emergence of electricity regulatory commissions came into picture. Then there was enactment of Electricity Act, National Tariff Policy came into picture. Then we had these renewable energy tariff regulations and the Renewable Energy Commission regulations or Rural Electrification Corporation regulations also came into picture. And if you see in the graphs out here, we are we started with wind, and wind has we are if we talk of wind, we are the fourth largest country in the world to produce power from wind. Biomass is a smaller amount, then you've got small hydel is there, then you've got waste to energy, which is a very small amount and has a big potential, then you have got a solar. So this is what we are talking of. So various types of renewable energy, we all know wind is available. It is onshore and offshore wind power plants. Both are available. Then solar PV is available. This is the solar photovoltaic, concentrated photovoltaic. The panels you see on the rooftops producing electricity. This is the part of it. Then solar thermal. Solar thermal is basically solar concentrated power, and it is through parabolic troughs, dishes, Fresnel connectors, heliostats, solar tower receivers. These are more in areas where the space available is less, but the falling of sunlight is more. The amount of sunlight falling is more, and there are a lot of stunning examples wherein solar thermal power is being used. Solar thermal power is little more efficient than solar PV, but it's more costlier also. Then you've got small hydel power plants up to 25 megawatts. Then biomass you can use bagasse, which is dry fibrous waste that is left after the sugarcane has been processed. Then rice husk, cotton stalk, mustard stalk, groundnut shell, groundnut coconut fronds, waste cotton stalks, roots of trees. Any kind of agricultural waste can be clubbed under biomass. Only thing required is you have to find out the viability of getting the energy from biomass, that kind of a biomass, right? Then is the cogeneration part. Cogeneration is you generate side by side. Municipal solid waste again is a source of energy, and there have been plants which have been set up for the production of energy from municipal solid waste. Then you've got geothermal energy. Geothermal energy is available from the crust of the earth, and it's not been explored much, but yes, the potential is there. Not much in our country. At some places where there are hot springs, for example, there's a place near Kulu, Manikaran Sahib, where you have got geothermal energy hub. Hot springs are there. Then hydrokinetics, wherein tidal power and wave technology is used. Now, just to give you an idea of how much solar we get out here, you can just see a lot of solar is available in Rajasthan and Gujarat, and wind is also available in Gujarat and Rajasthan only. But these are the areas basically wherein a lot of wind and solar is available. Geographically, almost the same, right? This is the potential available for renewable resources state-wise, and people can locate their own state. Punjab doesn't have any wind power potential, only small hydel power plants. Biomass, it's not listed here, but it should have been listed. Biomass, we have got a lot of potential available. And this is installed capacity and available potential vis-a-vis available potential. Just you can just see out here how much is available. काफी ज़्यादा availability है, so we can see. Now, solar in India, if you talk of India received the highest global solar radiation on a horizontal surface. According to solar energy experts, India has considerable scope for solar energy. And desert areas have the solar addition required for concentrating solar power technology. A 60 kilometer by 60 kilometer area can produce 1 lakh megawatts of power, which is huge amount. Even if India uses only 15,000 square feet of the square kilometers of the desert, it can produce 3 lakh megawatts of power, which will serve almost the entire nation. And then if you talk of small hydel power stations, this is the general arrangement. Usually there is a canal going around. They divert the canal and try to make a small head, and then they generate electricity and feed it to the grid nearby. Similar, and if you have it on the river, then in the hilly areas also it is possible, wherein you can have the natural head of the river is also available. Then we talk of these all the energy sources give us green attributes. We can earn renewable energy certificates, and all that stuff is also available. Now, biomass, if we talk of, and which is one of the most important from the point of the villages, is because you see every time, every year after year, the governments have been passing on the buck to each other and saying that the parali has been burnt, the rice husk has been burnt, and is causing a lot of pollution. Whereas that rice husk, if you talk of it, it has got a lot of potential and has a high calorific value. If you mix this, if we can somehow create a mixture, we'll just see here, then it will become a enviable option, not viable only, it is an enviable option to the coal also. So India has over 5940 megawatts of biomass power based power plants, which is out of which most of them are grid connected and some of them are off grid plants. So major share comes from bagasse cogeneration. Now bagasse cogeneration, why it is coming? Because it was in earlier the initial stages, it was um, the sugar industry, which helped in cogeneration, wherein the bagasse was used to generate power. Bagasse was used to generate the power, and around 115 megawatts from waste to energy power plants are also available. So, okay. And as of December 31, 2019, the grid detected biomass power generation is stood at 8.8 gigawatts, up from 4.95 gigawatts. And we are likely to surpass the target of 10 gigawatts very soon. The current availability of biomass is estimated about 500 million metric tons. And now, issue is कि इतना कुछ so much of it is available. What to do? And why are we not harnessing? Here you see the figure is 7,000 megawatts additional power could be generated through bagasse-based cogeneration. The country's 550 sugar mills. This is only the organized sector we are talking. There are unorganized sugar mills also available. These sugar mills were to adopt technically and economically optimal levels of cogeneration. Now, this is only from the sugar mills. If you talk of other sources, again, a lot of power is available. And it's just over 13%. For global also, it is 14%. So, for how do we use biomass for production of heat energy? Anything from the nature which can burn to heat, for example, charcoal, wood, mustard, oil, etc. For producing electricity, using the same method as oil, burn it and get energy either for state or a house. This is also required. Then waste biomass, crop and forestry residues, animal manure, food processing, waste yard waste, municipal and C&D waste, and sewerage, industrial waste, etc. They're all available, right? So, and then there is a new biomass also, which people say this is a new category of biomass which has come up: solar energy and CO2 converted via photosynthesis to organic compounds. There are a lot of algae which do this work, and only day before I could just decipher, they have made a solar cell out of bacteria. So this is a very good option available. Conventionally harvested for food, feed, fiber, etc. Right? Agriculture and forestry waste, crop residues, animal manures, food, feed processing. Now this all is very easily available in the villages. And the second problem is the of the transportation. So transportation is since it is available nearby, so it is available. Third problem here is the storage part. Now, if the village area of the or if the common land of the village can be used for storage of this biomass, then it becomes a very good option, right? Then this also comes under biomass, municipal garbage, and other landfill waste. Now there is a problem all around, and people have started complaining that this is the responsibility of the government. We also are as responsible citizens. It's our responsibility also to reduce our garbage and recycle. So municipal solid waste plants, and then here in landfills, gas to energy is also there, wherein they are trying to extract the gases from the municipal solid waste and trying to produce energy from that. Then urban wood residues from construction demolition waste, tree trimmings, yard waste, and discarded furnitures. So biomass energy retrieval from recycling, incarnation, and incarnator ash. Now, how do you retrieve it? See, what we do, usually we try to burn the biomass inside an incinerator, wherein we control the atmosphere of the incinerator, the supply of the oxygen and the air, and so that we get the maximum amount of energy and less amount of ash. And then, okay, let's come down to this case study. Now we have this is a case study of a Pura village, wherein biogas electricity has been used. Biogas option is considered largely as a cooking fuel, but here the need for considering decentralized electricity options and potential of biomass is analyzed. A field demonstration program was implemented in Pura village in South India to use cattle dung in a community biogas plant to generate electricity for services such as pumping, drinking water, and home lighting. Home lighting. Now, how does this work? They have a kettle shed. From that kettle shed, the dung is taken and to the house, or from the house to the fields, and the sludge is also taken to the fields. Then the cycle is working like dung delivery. How do you get the dung? You put it in the biogas plant. Then you have from the biogas plant, the gas is produced. It runs an engine generator set. From the engine generator set, the electricity is produced. It passes the lights also. It is used for pump sets also, and used in public street lighting also. And then the payment is also received. Now, earlier, whatever the biomass was being thrown as a waste or was being burnt just for the because they didn't have the um, space to keep it, or they didn't have the technology to harness it, not just being used to do this. Now here, what they have done is they have used the Indian floating drum design with the modified dimensions for cost reductions was used. The pure gas bar plants and the Pura gas biogas plants have capacity to digest up to 1.2 tons of cattle dung per day and produce approximately 42.5 metric cubes of gas per day. Sandbed filters were installed to remove excess water and convert the sludge into dung-like consistency for subsequent use as fertilizers. Now you see, once the dung is put, it takes time to start releasing the gas. So it's a floating dam technology under the Deenbandhu. It's called the Deenbandhu model basically, and been designed by IITs only. So there's one fixed drum and then there's floating drum. As soon as the gas starts producing, the drum is lifted up, and the gas starts oozing out, and you can use the gas for driving a turbine or for burning it as it is for as a fuel also. The filtrate, which contains the required anaerobic microorganisms, is mixed with the input dung. A 5 kilowatt diesel generating set is connected to a 5 kVA 440 volt three-phase generator for electricity generation. Out of the 87 households in the village, 39 already had grid electricity. So there were little rich people also who had the grid electricity, and there are around 103 fluorescent tube lights of 20 watts capacity connected biogas generated electricity. Then 47 houses opted for one tube light and 25 houses opted for two tube lights. They said, okay, one is okay. And then 25 of them went for two tube lights. Lighting is provided in the evening for 2.5 hours per day. Earlier, they never had light. Now they have light for at least 2.5 hours per day from this biogas plant. Even homes connected to the grid had lighting connections from the biogas system. Advantages of this biomass: widespread availability in many parts of the world, of course, in our country also, and wide variety is also available. If you talk of the calorific value of biomass for rice and wheat is approximately in the range of around 3000 kilocalories per kilogram. But if you mix it with the mustard or corn stalks or sugarcane stalks, the stability of the biomass also increases, as well as the calorific value also increases, becomes somewhere around 4000, which is approximately equal to the Indian coal right now. And generally low fuel cost compared with the fossil fuels. Biomass as a resource can be stored in large amounts, creation of stable jobs, especially in the rural areas. Because when you set up a biomass power plant, you need the manpower to drive that power plant. You need manpower to fetch the dung, put the dung inside, and all that stuff. Then developing technologies and knowledge base offers opportunities from technological experts, and CO2 mitigation is also there. Now, coming to small hydropower plants, smaller hydropower plants, as classified by United Nations Industrial Development Program, Development Organization, UNIDO, is any plant under 10 megawatts capacity. So, different classifications of pico, micro, mini, small, medium, and large power plants. And okay, now the how do you select the technology and how do you select the site for a small hydropower plant? And most of the villages where canal water is flowing or a canal is coming across the village. So small hydro technology is mature and well established in the market. It is available. There's no rocket science right now. It's a generally available thing, as is the biomass right now. Right? Improvements in equipment design, of course, they are being made. Materials, some materials are also used. How do we calculate? If you take Q as the flow of water through the pipe and H as the head, Q flow of water through pipe here will be meaning the through the river, and then the power which will be available from the flow would be QHGN, eta. So where G is 9.8 and N efficiency is 80% of the plant. We just are taking it, assuming it. It can be more. So if you see the schematic here, how it is done, you have to create a head wherein the head has to, you have to, from the head, if you push the water on the turbine blades will rotate and will produce the electricity. This is what is done in this part. So there are different types of installations in hydroelectric installations. You could have small low head plants, as in the small canals or rivers alongside, wherein you make an artificial barrage, and then you have a small turbine in the path of the water, which rotates and generates electricity, and is fed into grid substation located just near to the turbine. Then you have got medium size power plants wherein you have to build a small dam and you have to create a penstock, and then you may run a turbine. And in the reservoirs, you have in the high head plants, the water is stored on the top, right, and then it is working out, right. So we can call these hydropower plants as run of the river plants, or we can call them as pondage plants, or we can call as reservoir plants. Run of the river plants uses the available flow of the river only. A run of the river plant has little cumulative water, high costs, and intermittent generation also. For example, if it is installed on the canal might not be a perennial canal. It might work only for say a few months in a year, or and then, for example, if you talk of Ludhiana, there is Sidma Canal which flows along the city, and there are around 4 or 5 plants on that particular canal itself. But the issue is the canal is also not running perennially. It runs for 2 months and stops for a month, and then again runs for 2 months or so. And the other problem is that once the lot of waste is also being dumped by the people inside the canal, and that waste also disturbs the functioning of the turbine because it gets entangled in the turbine. So costing, if you talk of it, is high because we have to maintain that infrastructure for the year long. Then pondage plants, cumulative water flows permits the flow of water for a few weeks. Pondage plants can work only also work when the river level is low. Then reservoir plants, they usually it's not a small hydropower plant. Bhakra and all, they are all reservoir type power plants. How do you plan a small hydropower plant? Uh, we need to look at the control of the national and regional law. Is there any law which prohibits the holding of water at that particular place? Who is using the water and how is he using? Then study the hydrogeological and hydrogeographic sides of the area. You have to find out how what is kind of rock or what is the kind of soil available, and then check the principal parameters and publicity of the project, and you have to tell the students. Now, what are the positives of the hydropower plant? You have the positive is that there are no emissions. There's it's a mature technology, renewable energy resource with high efficiency, long life, skilled work is required, and change in using areas. The negative impacts are social impacts. Then there is high initial capital costs, impacts on the river flows, and high cost of dismission. Then coming to the most important of these sources, renewable sources, and which can be easily tapped with a mature technology, is the solar power plants, and more so grid tied solar power plants. Why we are talking of grid tied solar power plant is that it is very easy to integrate the solar power plants with the grid and ensures the energy security for the region also. So, what are the advantages? It is easy to install. There are very less number of components. If you can just see on your right out here, you have only one solar panel is required, one inverter is required, one motor is required, and then you can feed it to the grid. Grid can supply power. Disadvantage: no power if the grid goes down. This is because a solar power plant a solar inverter always requires a reference voltage to start generating. So it has to be given a reference voltage before it starts generating. And there are a number of technologies of solar cell available right now. Single crystal or monocrystalline silicon is available, polycrystalline silicon is available, and then thin film, for example, amorphous silicon or cadmium telluride is also available. But thin film is a little costlier. The technology is not being exploited as it is, and we are mostly talking of monocrystalline and polycrystalline panels. Monocrystalline are usually most efficient panels, commercially available modules 11 to 14%. This has increased a little bit in recent days, come to up to 17%. Most expensive to produce. Circular round cell creates wasted space on the module. There is this kind of a wasted space is also available on the module itself. Then polycrystalline silicon modules, they are less expensive to make than the single crystal modules. Cells are slightly less efficient, only 10 to 12% efficiency. Square shaped cells fit into the module efficiently using the entire space. So they use the entire space. Now, earlier we had a limitation on number of cells on the panel and the wattage. Now the voltage is increased. Earlier, we used to have only 330 watts panel, 330 watt peak panels. Now we have got 760 watt peak panels also available. 800 also available. Amorphous thin film, they are the most inexpensive technology to produce. Metal grid is replaced with transparent oxides. Efficiency is low, 6 to 8%. Can be deposited on flexible substrates and is less susceptible to shading problems. Better performance in low light conditions also is available. Right? Now, how do you select the correct module? Somebody tells you to find out the or design a solar plant, power plant for a village. We need to find out the size of the panel first. What is the area it is going to take, and then what is the voltage level it is going to sustain or generate. What is the availability? How much warranty is available on the solar panels? Usually, on the panels, it is 25 years as of the current market practices we talk of, And how are they supposed to be mounted? Usually they are mounted facing towards south with an angle, azimuthal angle, which is specific to the place of installation. In Ludhiana, it is 17 degrees. Chandigarh also is around 17 degrees. And also the cost per watt of the panel, whatever is available. That is the commercial aspect. You can always look at it. Sorry. Then, how do you select the site? You have to face true south. It should be free from shade. It should and correct magnetic declination. That angle we are talking of, azimuthal angle, that is also required. General considerations are weather characteristics, what is going to be the wind intensity, estimated snowfall. When you install the plant, sorry, the structure has to be such that it ensures it is able to withstand a wind speed. In Punjab it is 150 kilometer per hour wind speed. It has to sustain, it must do that. In snow areas where snow is falling, you have to find out how much snow is going to fall and not damage the panel. Then side characteristics, corrosive salt water. Now, why are we talking of water? Because these panels need to be washed. That is the drawback. Otherwise, if you do not wash them and these panels, the efficiency of the panels is going to go down, and there is going to be a problem. And then there should not be any animal interference. You are not supposed. If, for example, if it is installed in a village field, and if the cattle is going to go inside the field, there is going to be a problem. Human factors, theft protection, aesthetics. Sometimes the panels are not looking nice. That also is a issue. Or thieves can also strike at some places. Then load and use of time. Now, how is the load varying, and how are you going to use the power being produced by the solar power plants? And then this is from the power conditioning equipment. Conditioning equipment here is the inverter. How much is the distance to be transported from the inverter? Now, larger the distance, larger will be the voltage drop, because the larger will be the length of the cable. And if the cable length is larger, the power you will not get the exact voltage. Then accessibility for maintenance is also required. People should be able to go and wash the panels and check out whether there is growth of any tree or all that can be cut out. So with this, I come to the end. But before I end, I will also talk of the solar pump sets, which is another viable option available for the villages, and is being promoted in a large way. Up to 5 HP, it is highly recommended. People should go for solar powered pumps, and they're highly efficient right now available. And there's a lot of government subsidy also available in that. So with that, I come to the end of the session. In case you have any questions, I shall be free to answer. Yeah.